Okay, so today what we're looking at is multiplying and dividing rational expressions. And what you're going to notice is it's not much different than simplifying. Because to simplify a rational expression, yesterday we said that it had to be written as a product. It had to be multiplication for us to be able to simplify. Well, this is multiplication. So we can actually think of this problem as this numerator times this numerator over this denominator times that denominator because it's multiplication. Okay, so take a moment and write that down if you're taking notes today. Okay, and once we have an expression that's written as multiplication, then we can simplify, we can reduce, we can cancel. All right, so I'm just going to start with the numbers here. I see a 12 and a 9. 12 and 9 have a common factor. What is it? 3. So we'd say 3 goes into 12 4 times, and 3 goes into 9 3 times. Okay, now I have 25 and 40. Do 25 and 40 have a common factor? Yes, 5. So 5 goes into 40 8 times. 5 goes into 25 5 times. And now nothing else. I think I'm done with my numbers. That's all I can do with the numbers. Now I'm going to check out the variables. I have an x cubed and an x squared. So I can say 2 of these, cancel with 2 of those, and leave 1. Or once again, when you're dividing like bases, you subtract the exponents. You can think about it that way. All right, so the numerator, we have 4 times an 8 times an x. Well, 4 times 8 times x is 32x. And in my denominator, I'm left with 5 times 3, which is 15. Okay, and the same process would occur whether I'm multiplying 2 rational expressions or multiplying 3 rational expressions. It's exactly the same thing. We multiply all the numerators, multiply all the denominators, and reduce. Now, I'm actually not going to multiply the numbers and make them bigger. I'm just going to leave it as a product. Okay, now with these, we have a binomial and a trinomial. So what do you think we need to do with these binomials and trinomials if possible? Factor them. Okay, in the numerator, the 5x minus 25. Will that expression factor? Yes, it has a common factor, a GCF of 5. And when I factor out the 5, I am left with
X minus 5.
X minus 5. Now let's take a look at this trinomial. Does it factor?
Yeah.
Yes. So it's going to factor to a binomial times a binomial. And what are those binomials? Very good. X minus 5 and x minus 4. So really what we're left with in our numerator, and you don't have to rewrite this. I'm rewriting this so we can see all of the simplifying occur in a minute. A product here and this product here. You can put that in parentheses if you want. You don't have to. Okay. Now, everything is written as multiplication. We have a product in the numerator and in the denominator. When I have all multiplication, then I may cancel. Okay? We clearly see that these match. So x minus 5 is a factor of both the numerator and denominator. So those will cancel. Hopefully you see 5 and 15. 5 goes into 5 one time, and 5 goes into 15 3 times. Now, do you see the 6 and the 3? Okay, so we can say 3 goes into 3 once, and 3 goes into 6 twice. And I'm going to reevaluate, see if there's anything else that can simplify. simplify, and I do not see anything, and it appears in the numerator I'm only left with a 2, and in the denominator I'm left with an x minus 4. Ooh, 2 and 4. Should I simplify those?
Don't do it.
No. These cannot simplify because this denominator is subtraction. This is not a product. I can't break in there. That's one of our no-nos. Okay. So, I want you to try 3 and 4. If you have a question,